Hello everyone, welcome back to my channel. Today is the day that we are going to talk about Elasticsearch and Elasticstack actually, and where does it come from, why it is so fast, and where to use it, what are the advantages and the disadvantages of Elasticsearch and Elasticstack actually. So before we start, we should understand where Elasticsearch exactly comes from. So when we understand what is actually which methodology exactly Elasticsearch uses, we can understand what is behind the Elasticsearch, and we can move on within use cases, when to use Elasticsearch and when to use SQL based databases. So first, before we understand where Elasticsearch comes from, we should understand that Elasticsearch didn't come up from somewhere else. It's already using some kind of methodology which was discovered before from a foundation, and they already have a product for it. So they are using this product for indexing documents and giving some results with that. But for this product, while we are going to talk about this, you have to use your index list, and you have to create your own indexing query and query parser methodologies to look for your data inside your documents for indexing actually. So as I told you, we should understand this product first, where does it come from, and then we can move with the Elasticstack and Elasticsearch. So first thing we are going to talk about, the product name is Apache Lucene. So this is the main answer of the question of where Elasticsearch actually come from. Apache Lucene is a full-text search library created by Apache Software Foundation. Basically, it creates a library for you, and you can look for full-text search inside of this library. It is the core of this Lucene product is the indexes. Actually the same in Elasticsearch, and these indexes are created by you if you have a list, and if you don't have it, it will make an analyze for you to create the best library. So what Lucene actually do this is using inverted index methodology. This inverted index methodology, basically the answer of this code means instead of mapping pages to the keywords, maps keywords to the page. So you are looking for a page, you don't have to give some full of lists of documents inside of it. You can look the pages from keywords. You are indexing the pages with the keywords, and then when you look for the keywords from your text, you can find your document easily and fast. So how Apache Lucene works? As I told you before, inverted index methodology is the main methodology of Apache Lucene works. As you can see it from the page, from the right of the screen, there is like three documents, and they have different sentences inside, and there are common words which are going to be deleted from the inverted index table. While you were indexing some kind of documents, you are creating an inverted index in Apache Lucene. The terms that are going to be in an inverted index, they have the unique IDs and the documents that are matched with these terms. So for stop word list, as you can see, these are the common words and pronouns and proficiency in the English, and a, and, around, every, for, from, in, is, it is the a stop word list can mismatch the Lucene works methodology. So they are getting out of hand, and you have unique terms that are in the inverted index table. As you can see in here in ID2, we have a blue term, and it's like a match with the document 1 and 3. So we are looking for a kind of term with the blue. The documents 1 and 3 are going to be analyzed, and we are going to have a result from that position. So what is actually inverted index methodology does? It filters, cleans, and analyze your document and create an inverted index table. And this extracting words means removing common words, as I told you in stop word list, and make all the words lowercase, because we don't want to have, for example, for blue term, some kind of letters could be uppercase, and it's going to be a problem for us to have these terms more than one. So this is the main problem if we doesn't make the words lowercase. So when once document is indexed, we are adding search functionality to these Apache Listen. And how are we going to do this? We are going to use index search and query parser. Index search basically is creating this search functionality, and we can use different default methods in here. And query parser is going to parse our query while we were looking for some kind of index inside of our inverted index table. So we should wisely choose our query parser and index search while we were creating some Apache Listen configuration, and then we are going to have our results as fast as it could be in Apache Listen. So I just gave you the basic methodology in Apache Listen product, from which was created by Apache Software Company Foundation. So we are going to talk about Elasticstack right now, and basically Elasticstack use this base, Apache Listen base, for creating its configuration. And also it is not popular as much as like Elasticstack, but Solar is the another product which use the same base from Apache Listen. So when we go to Elasticstack, what is Elasticstack? Actually, Elasticstack is the tree of a guy who uses these and creating this Elasticstack. Elasticsearch, Logstash, and Kibana. These three guys help each other to give you search, analyze, and visualize data in real time. This is the main problem, guys, today, to creating, searching, analyzing, and visualizing data in real time. Real time in here is like the most important thing that can Elastic do. So giving it in real time and taking data from any type and then serve it any time, it is absolutely enormous technology that you can have on your tech stack. So you should wisely use it and understand how it works. So like, if I just give you how it works, Elasticsearch creates, and it just heart of the Elastic stack. So when we move on to the Elasticsearch, it will give you the great search experiences inside of your documents and indexes. And what is exactly when to use Elasticsearch is getting fast and relevant results. That is the main topic, because it depends on like how your text is just getting inside to the Elasticsearch. It doesn't matter you just mismatch or mistype any kind of word or letter, it doesn't matter. Elasticsearch algorithm is going to find you the best result inside of your indexes, and you will get the result as fast as it could be and the most relevant one. When to use Elasticsearch is actually when you have a use cases like logging, matrices, security analytics, and business analytics is the most important use cases that you can use it in your projects. For example, you wanna log your databases and you wanna look for which gender is actually buying a kind of product, and maybe the which age, maybe 10 to 20 ages are buying some toys from your product, and you want to look for where actually they are buying this from, which country are they buying from. So this are the important logins for your marketing methodologies, and you should use on these logging and matrices and business analytics use cases Elasticsearch. It is the main brain of the Elasticstack. So these other two guys, Logstash and Kibana, helps Elasticsearch to do these analytics. So when we move how Elasticsearch works, as you can see, there are 4 words that we need to know about how Elasticsearch works: indexes, segments, nodes, and clusters. Basically, when you create a default Elasticsearch database, you have a default cluster and default node inside of this. And you can think as a cluster as a different kind of collection to have nodes inside. There could be so many nodes you can create by yourself, but default you have node 1, and all the nodes have their unique IDs. And inside of these nodes you have segments, and in these segments sequentially look for indexes that you are looking for inside of a file, means data mean index in Elasticsearch. So when you give a data inside of Elasticsearch, it's indexed and stored inside of node inside of the cluster. And let's imagine you have 100K of data inside of your Elasticsearch and you want to store it inside of the cluster and the node. So let's imagine you have a one cluster and one node. You uploaded 100k indexes inside of this node, and while at the time you just get these data out of control and you wanna have a result less than 10 seconds. So right now when you upload this 100k data inside of node 1, you are having a result at 10 seconds, and it's a problem because you are using this endpoint as much as it could be and you are using very often, and you want to have response less than 2 seconds more, for example. But right now it's 10 seconds. It's a lot more than normal. So while you want to have something fast, this is the good thing, guys. You can use it in Elasticsearch. You can create different nodes inside of this cluster. In each node inside of this cluster have their own roles, but they are serving for the same goal. So when you have 100k of data and you want to store this data inside of this cluster, you can divide this data into 5 nodes and you will have 20k inside of these each node. So good thing is that if you want to look for an index right now, Elasticsearch is able to do parallel search. So when you are looking for an index inside of these nodes, you will have 2 seconds to find this index. You remember that we have 10 seconds to find the index that we are looking for, but right now we can find this index in 2 seconds because thanks to the Elasticsearch parallel searching, it will help us to look for the segments and sequentially and parallelly to find our index inside of this cluster. It is a good thing to have, and you can create of these nodes as much as it's possible. And also there is a good thing to have. Let's think that these nodes are SQL databases inside of your server, and you have different 20k of data inside of these SQL databases. When you lost, for example, node 2 inside in the data inside node 2 in here, you are going to lose this data if you don't have backup. But in Elasticsearch, there is a good thing. These primary segments have their replica segments, and they have these replicas in the other nodes. So for example, you have a data in node 1 and you lost the node 1, but there is already replica of segments to node 1 inside of the other nodes and node 2, 3, 4 and 5. So when you lost node 1, you are not losing the data. The data is getting from these replica segments, and you are going to have your data back again. So it is a very good way to not losing your data, keep it secure and reliable, because the reliability and maintainability is one of the most important things in our coding modern environment. So you should have it. So the last thing maybe comes up on your mind: how do Elasticsearch gives the best result for me? Maybe I'm looking for something else, but how Elasticsearch every time comes up with the best idea to me? So in here, thanks to the Elasticsearch algorithm development team, they are using one of the most important 4 algorithms for relevance scoring. Because the relevance scoring actually means that giving the best results of your index searching. So these are the 4 scoring algorithms that are using by the Elasticsearch. Basically, I want to give you the little bit detail about these algorithms. You don't have to basically configure any of these scoring algorithms because they are already used in your Elasticsearch environment. So you can use it how you wanna have it in your Elasticsearch. You don't have to configure or define anything. It will give you, it will do it for you. So for TF-IDF, just going to evaluate the importance of keywords, rewarding terms that appear frequently and target documents but not in the other documents. So you are giving some rewards if they have the index unique inside of the document. This is basically the work of TF-IDF scoring algorithm methodology. For RankBrain methodology, this is an AI-driven algorithm developed by Google that uses machine learning to process queries to achieve better results. Basically, it's developed AI-driven algorithm developed by Google. For the vector space model, it works by representing documents and queries as vectors, enabling comparison between the documents and ranking to them. So it's basically the same methodology with the TF-IDF, but you have vectors inside and here. For the last one, and the latent semantic analysis is identifies the latent relationships between the terms using a statistical approach. So it will basically do with the same thing as the statistical. If you just compare with the TF-IDF and vector space model, it's basically do the same thing but on a statistical way. So there are important things that we are going to talk about. What are the advantages and the disadvantages inside of Elasticsearch? So maybe you can consider it is fast and give me the best result. So what is the disadvantage actually? Is there any? Yeah, of course, there are some disadvantages of Elasticsearch. Basically, if you are looking for some relationship between entities and if you want to create some SQL-based relational database in Elasticsearch, it is not possible because it's a NoSQL database and it is like not possible to create relational relationships inside of your Elasticsearch. This is the main disadvantages of Elasticsearch, but the best advantage is that having best results from index data. So while you are going to configure your project with the Elasticsearch and SQL databases, you should really consider your use cases, which technology fits you well. So while you are looking for the best result from your data, you can have Elasticsearch while you are having this data and indexes. But if you are looking for some relationship between your entities and if you want to create some configuration between your entities, you should go and check out the SQL databases. So basically, these are the main advantage and disadvantage of these Elasticsearch based applications and configurations. Last but not least, I want to talk about Elasticstack other two guy called Logstash and Kibana. Basically, Logstash listens to your SQL-based databases logs to create a stream between to your SQL database to Elasticsearch. So when you have kind of insertion, update, deletion, it will just keep track on these loggings and you will have the fresh data on your Elasticsearch. Basically, the Logstash helps you to have the latest data from your SQL database or any kind of data source. You will have it on your Elasticsearch from a stream. It will give you a stream to create a data river actually. So for the Kibana, if you wanna visualize something in your data, for example, you have a data of people who just buys the kind of a toy in your products and they have ages in the data. So you want to look for where they are actually come from and you can have a visualization of this data from the world map and you will see where actually buy these toys from and what are their ages, and you can see the pie charts, bar charts, scatter matrix and all of these in Kibana. So these three guys help you to give you best result in your index documents, visualization and actually streaming your data in somewhere maintainability and reliability. You should consider about using these technologies inside of your projects, but you should choose your technology wisely, because if you do not have to use these technologies, you are just going to give you some pain in your butt. So you should think wisely and you should consider your use cases before you should start to use these technologies. For today, these were all things that I'm going to talk about Elasticstack and Elasticsearch. I hope I just give you a kind of angle about what is actually Elasticsearch and where does it come from, because you should consider about the technologies where they actually come from. You shouldn't just say that they are just fast and we use it. This is the best thing to do. You should do some research and understand where they actually come from. So I hope I didn't make any mistakes, but if I did, just tell me know that what I did so I can learn with you. Take care of yourself guys. See you in the next video and goodbye.